Hi, welcome again, learners. So today we're going to discuss. This is my second attempt on calculation in anything concerning photogrammetry. So this is a special request from you, my online learners. Let me tackle this question. So this is a lecturer from Matili Technical, Tibet, CDEC, accredited. I'm going to tackle a question on knec 2021 November series. So sit down, get your pen and pencil, and we go ahead and we calculate everything. So this is a special thanks to all my trainees in the school and the online community that has been helping me and that has been gaining a lot of knowledge and also a lot of feedbacks from you guys. So this is a special thanks for you. So keep it up. I'll be working more of your request and we can move on together. So let's go directly to the question. So this is the knec 2021 November series. So this is a question that I was to tackle, but due to the demand, I saw it best for me to do it online here. So let's go ahead. You can download the question paper. I didn't find that question paper on EasyTibet, so you can look at it in your nearest library or any other place where you can get that information. So the following information were observed during an aerial photography. So we had the flying height of 1500 meters, then we have the camera focal length of 152 millimeters, then we have the distance measured to a building image. So there is a V low and a V high, both in millimeters, so they were given there. Taking the ground datum levels as 100 meters, estimate the height of the building and the height of the camera. So those are the things that we need to calculate. So this is a 12 marks question. So this 12 marks, that is a lot of marks that we can go ahead and tackle. So I went on ahead and did some small illustration. So this is just a small illustration. So this is the building. This is where the aircraft was flying to. F here we have the focal length, capital H, this is the flying distance. Then I have illustrated these both distance. So this is a small v c, that is the v low, then v b small, that is the v high. Then here we have the same representation of both our two informations. So here we have the height of the building being represented by B and capital C. Then here we have our V that will be used later. Then here we have our E. Then here we have our O. So all these data were used in order for us to have the representation rightly here in our illustration. So considering the side of the high building BC, capital BC, so here we have capital BC in this figure, and it sequence image CB, small CB here on the negative. So capital B here being represented, so this capital B here is vertically above capital C, and in the plan the two coincide, but on the photograph the side of the building here small being represented by small CB will be observed as well as the roof, and in this building will appear to be leaning outwards from the center of the photograph. So there is the center of the photograph being 0, and it may be shown that the distortion of the image is proportional to the distance from the photo thumb point, this v, small v here, which is particular in case coincide with the principal point P. So the principal point P are here and here. In the figure, it shows the building, capital B is C, shown for the sake of the clarity, which is based on the datum plane, and with capital B at the height that is the above that of the plane here. So remember that so long as the small p found here on top to the capital P found there at the bottom is truly vertical, then the small v and the big V, or the small p and the big P, the capital B and the capital C, the small c and the small b are all contained in one vertical plane. And since here B is vertically above C, this vertical plane intersect at the plane of the negative. So you remember those are the properties of a photograph. And since the two planes intersect in one line only, so the small v, small c, small b must be collinear, and the displacement of the CB is radial from the plumb line of V. So you remember that. Those are the concepts that we are going to be using. Then also remember, we'll be considering similar triangles in order for us to get the equation that will follow in our next procedure. So here in our next procedure, it will be seen that the distortion due to the building height, that is the height BC, is so the distortion that is brought here from the building height. There we have the BC, that will be so the distortion being represented by the photograph. So small BC, that's where the photograph is formed on the plane, so will be equal to a small h over big H multiplied by V high. So this is the height of the building, and this is the height of the flying. So that is the flying height of the building. But here you can remember I had similar representation there. So the distance here, the distance V to C being represented by the V low, and V to B being represented by the V high. So those are the data that we were given in our questions there. So BC is the difference between those two. So the V high minus the V low that we were given on our question. So you remember all these data were from here, our question paper. So by subtracting those two, we'll get our BC. So this is the small BC, that is the distance that is formed on the vertical plane on the photograph that is being taken on the height, the top of the aircraft. So this is where the image is being taken, and that is represented by the small b and c in our equation. Remember that. So after getting that in millimeter, remember this is in millimeter, we need to calculate the height of the building, and from our formula earlier, so BC is equal to the height of the building over the flying height multiplied by V high. We do the same. So this answer we have already gotten here, BC. These were going to replace there in our equation. So BC as being 4.43 millimeter is equals to the height of the building over the flying height. The flying height is in meters. So by multiplying it by 10 power 3, I'll have converted it into millimeter. So I need to have values that are similar. So I can't multiply millimeter and meters, it will give me a wrong answer. So then we come here. So V high, we were given the V high in the equation here. So our V high is there, so that is 102.63 millimeters given to us there. Remember, that's why we're getting our V high. So by multiplying it, I'll get 64,747.15 millimeter. So I need to change this back into millimeters because that is the data that will be easily solved. So by converting these millimeter into meters, I'll get a height of 65 meters. So that's the height of the building. By doing that, I'll have already answered my first question here. So estimate the height of the building. And my next question, the height of the camera. So that is where we are going. So we need to calculate the height of our camera. So from this data, we have already gotten our height of the building. Here again we come. So I need to compare both our triangles. So you remember that. By comparison, the consideration of the similar triangles small BVO and EBO. So these are this is where our triangle is. So small B O being seen here on our consideration. So there will be that is VBO. This is the triangle that I am looking for. So by comparison of that triangle and the bigger triangle, that is EBO. So these two triangles share a common axis. So by comparison of those two triangles, I'll have my equation as V high over F, that is the focal length, is equals to capital VC over height minus 100 plus 65. So this is the distance. So I'm comparing my distances. So the distances that I had here. So this F, that is the distance here. Our capital H, that is the distance from O to E. And then by comparison of the where we had all our other data. So this similar triangle comparison, there is where our formula is derived from. So by considering that triangle there, then in our second consideration, we consider the similarities of triangle VCO and VCO capital. So there is a small VCO and capital VCO. So this is the comparison of those two triangles. So in our first, this is the VCO, the triangle found here. And then we have the bigger triangle also found here. Those are the comparison of those two triangles that I have formed sharing a common axis. So this distance remains as F, here O2, and that this remains as H. So the other here, we needed to subtract this distance of the height of the building. That's where you saw us minusing that 65 from that. Then our 100 was found here. So this is the we have the taking the ground datum level as 100 meters. So that was the displacement from the ground. That's where you saw us adding the 100 plus 65. But here in our case, so you only subtract the 65 in order for us to have the exact distance that was supposed to be here. So that is the distance that we were comparing in order for us to have the same. So those are the two considerations. So by comparing both those, two answers. So these the distances on the top of the triangle compared to the length found here on the axis. So we are comparing these distances and these distances because those are the distances that we somehow know. So those are the comparison of our similarity in triangles. Remember, these formulas were gotten from that concept. So by comparing both these two answers, I'll have something in common, and this capital VC, this is the distance that is unknown to us. So capital VC, that is the distance found on the bottom there. So on the bottom of our illustration here. So those are the data that we are supposed to be using. So remember that by comparison of these two by cross multiplication, I think that's something that you can solve. So V high, we have been given that on the question, and also for V low, we have been given that on the question. Our F, that is the focal length, we have been given that in the equation. I know some of you will ask, how comes I have used directly values having millimeter and here on this side value having meters? So this is just a simple concept. So here, even if I was to multiply by this 10 power negative 3 and here down 10 power negative 3, those two values will have cancel each other. That's why you have seen I just written that directly. So by comparison of our first formula and the second formula, our VC becomes, so this is a representation of our VC. So by cross multiplication of both these two values, so I think cross multiplication should be easy for you, that I just went ahead and did that directly. So you remember cross multiplication, you multiply across each other. So that's when you find the values. So VC will be equal to 102.63 over the F multiplied by H minus 165. That is the addition of the 100 plus 65 is equals to this, that is 98.2 over 152 multiplied by H minus 65. So this is just simple. So we open our brackets. So the H, we move that on the same side. Then all our other values, we move them on the other side. So this is just a simple multiplication and somehow division, moving from one point to another. By doing that, we'll have remain with H on one side simplified and the other whole numbers on the other side. So by dividing the value that we have here to that of the total here, we'll get our flying height as 2382 meters. So this is how simple we calculate this equation. So we have solved the height of the building and the height of the camera, a total of 12 marks. So that was just simple like that. I think you can go ahead and learn something, so you can practice that. I also found in other similar questions on the knec. So remember to subscribe to the channel for more education videos later. For requesting, you can leave there down a comment. I'll be glad to hear from you. So thank you, and that will be all for now. So until